Alright, so in this problem, I have 4 to the power of x plus 16 to the power of x is equal to 64 to the power of x. Now, 16 I can rewrite as 4 squared. So now I have 4 to the power of x plus 4 squared to the power of x. And now 64 I can rewrite as 4 to the power of 3. Now I'm going to rewrite this as 4 to the power of x squared. 4 to the power of x plus 4 to the power of x squared is equal to 4 to the power of x to the power of 3, because I can switch the places of these two. Now I'm going to let 4 to the power of x equal to the variable u. So now I have u plus u squared is equal to u to the power of 3. Now to solve this, I'm going to start by factoring out, I'm going to start by subtracting u squared and u on both sides. So then these two cancel out, and now I have u to the power of 3 minus u squared minus u is equal to 0. Now I can factor out u, so I have u times u squared minus u minus 1 is equal to 0. Now to solve this, I can divide this into two parts. U equals 0, and u squared minus u minus 1 is equal to 0. So u equals 0, this is already a solution. And to solve u squared minus u minus 1 equals 0, we have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. So I'm not going to waste your time actually plugging in everything into the quadratic formula, but you should end up getting u equals 1 plus the square root of 5 over 2. And u is equal to 1 minus the square root of 5 over 2. So now, remember how we set 4 to the power of x equal to u. So first, I have 4 to the power of x equals 0, and there's no solution to this because you can't take the power of a number and make it equal to 0. So now I have 4 to the power of x is equal to 1 plus the square root of 5 over 2, and 4 to the power of x is equal to 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5 is going to be a negative number, and you can't take the power of a positive number and make it negative, so this is no solution as well. So I have 4 to the, I'm left with 4 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So now I have x times log 4 is equal to log of 1 plus the square root of 5 over 2. Now if I divide both sides by log 4, these two cancel out, and I get x is equal to log of 1 plus the square root of 5 over 2 over log 4. Alright, so in this problem, I have 7 to the power of x plus 8 is equal to 8 to the power of x plus 7. So to start, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 7 to the power of x plus 8, that's going to equal 7 to the power of x times 7 to the power of 8. And a to the power of x plus 7, that's going to equal a to the power of x times a to the power of 7. Now I'm going to divide both sides by 7 to the power of 8 times a to the power of x. So then these two cancel out, and these two cancel out, and I'm left with 7 to the power of x over a to the power of x is equal to a to the power of 7 over 7 to the power of 8. Now this is the same thing as 7 over 8 to the power of x is equal to a to the power of 7 over 7 to the power of 8. And now I'm going to take the log on both sides. So now I have log 7 over 8 to the power of x is equal to log of 8 to the power of 7 over 7 to the power of 8. Now if I have something in the form log a to the power of b, I can move this exponent b to the front. So this can equal b times log a. So log of 7 over 8 to the power of x, I can move x to the power front. So now I have x times log 7 over 8 is equal to log of 8 to the power of 7 over 7 to the power of 8. Now Now log of a over b, this is equal to log a minus log b. So log of 7 over 8, that's going to equal log of 7 minus log 8, which is equal to log of 8 to the power 7 minus log of 7 to the power of 8. Now if I divide both sides by log 7 minus log 8, these two cancel out, and now I have x is equal to 7 times log 8, because remember I can move the exponent to the front of both of these, minus 8 times log 7 over log 7 minus log 8. And from here, if you plug in all the values of log 8 and log 7 into the equation, you get x is equal to negative 0.4399. Alright, so in this problem, I have x minus 4 to the power of 4 is equal to x to the power of 4. So to solve this, I'm going to first start by subtracting x to the power of 4 on both sides. So then these two cancel out, and now I have x minus 4 to the power of 4 minus x to the power of 4 is equal to 0. Now I'm going to rewrite this as x minus 4 to the power of 2 times 2 minus x squared times 2 is equal to 0. So if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x minus 4 to the power of 2 times 2, that's going to equal x minus 4 to the power of 2 to the power of 2 minus x to the power of 2 times 2, that's going to be x squared to the power of 2. Now this is equal to 0. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So x minus 4 squared to the power of 2 minus x squared to the power of 2, that's going to equal x minus 4 squared plus x squared times x minus 4 squared minus x squared. And this is equal to 0. And now if I expand this, I get negative 8x plus 16 times 2x squared minus 8x plus 16 is equal to 0. So this gives me two equations. I have negative 8x plus 16 is equal to 0, and I have 2x squared minus 8x plus 16 is equal to 0. So for negative 8x plus 16 equals 0, I get 16 is equal to 8x, meaning x equals 2. So this is one solution. And for 2x squared minus 8x plus 16, if I factor out 2, I get x squared minus 4x plus 8 is equal to 0. And now to solve this, I'm going to use the quadratic formula, which is negative b. So negative of negative 4, which is positive 4 plus or minus the square root of b squared. So negative 4 squared, which is 16, minus 4 times a, which is 1, times c, which is 8, all over 2a, so 2. And this is equal to 4 plus or minus the square root of 16 minus 32 is negative 16 over 2, which is equal to 4 plus or minus the square root of 16i over 2, which is equal to 4 plus or minus 4i over 2, which is equal to 2 plus or minus 2i. So these are my three solutions.